Today we'll start with OSPF. Okay, OSPF. We'll start with the CCNA level, then we'll move to the higher levels. Okay, so see the OSPF is a link state routing protocol. Okay, it is a link state routing protocol. What does OSPF stands for? Open shortest path first. Okay, then this chapter objective will see link state routing protocol, introduction to introducing OSPF, SPF algorithm, OSPF packet types, configure and verify single and multi-area OSPF. Now, link state routing protocol means each router is aware of all other routers in the area. Okay, there is a concept of area introduced over here. Updates are sent when a topology change occurs. Okay, like our EIGRP, incremental updates, or you can say triggered updates. If there is no change in the topology, updates are not shared. If there is anything changed in the topology or in the network, then the updates are shared. Type of updates are known as triggered updates. Triggered updates. Okay, updates are event triggered. Fast convergence. Okay, so OSPF is having faster convergence. Now, advantages of link state routing protocol.
Sorry, Qayyum, can you go back to the previous screen? I just want to note down some points.
Yes.
Okay.
Now, advantages of link state routing protocol. Okay, cost metric reflects the capacity of the link. Triggered updates make the convergence faster. Okay, when we are getting updates that are, if any changes happen, then only if the router is getting update, then the router will converge faster. Each router have full picture of network, less possibility of loops. Okay, each router will know about the network, the overall network. So there is less possibility of loops to be created. Careful network design, small dB size and SPF calculation. These are some advantages and there are some disadvantages. Topology database and adjacency database and forwarding database. Okay, so more CPU and router resources. Why we need more CPU and router resources? Because here we have a concept of area. So if a router is running in two areas, it will need more CPU resources. Strict hierarchical network design is required. Otherwise, kill CPU. LSP, link state packets flood in initial discover. Okay, so we'll see these all things. Now let us take an introduction to OSPF. It is a classless routing protocol, supports VLSM, CIDR, allows creation of areas and autonomous systems. It uses cost as metrics. Okay, metric value is cost. It has no hop count limit. Supports both IPv4 and IPv6. OSPF routes an administrative distance of 110. Okay, so I have a Word document that I have created over here at the CCNA level for introduction. So you can go through this Word document. Standard protocol, it uses SPF algorithm, or you can say Dijkstra's algorithm. Dijkstra was the name of the scientist who introduced this algorithm. Unlimited hop counts or routers, you can say. Metric is cost. Now the cost is calculated on the basis of this formula: 10 raised to 8 divided by bandwidth, 10 raised to 8 divided by bandwidth, So 10 raised to 8 divided by bandwidth over here. Then if I see the cost of a serial link, the serial links will be having a bandwidth of 1544 kbps. Okay, so what I did, I calculated the cost and I got a 64 as the cost of serial link. Okay, then the AD value is 110. It is classless routing protocol. See, I'm just giving you a revision of CCNA. It only supports equal cost load balancing. Updates are sent through multicast address 224.0.0.5 and 224.0.0.6. Fast convergence. Now, what is convergence? When you run a routing protocol and database is exchanged among the routers initially, it is known as convergence. Okay. Hello packets are sent every 10 seconds and dead interval is 40 seconds. Incremental updates, or you can say triggered updates. Triggered updates. Okay. Introduces concept of area. Okay. So this is something in Ospf introduction that we all know. Okay. Now these are some states through which the router goes before forming a full neighborship. Okay, so these are the states that are there over here. They are listed over here. You can see the down state establishing bidirectional communication. The first state is down state. In down state, both the routers don't know about each other. We have not advertised any network. We have just created the instance by giving a command router ospf1. We have not advertised any network, okay, on both the routers. That is my down state. Both the routers don't know about each other. Then comes my initialization state. In initialization state, you can say a router that is being advertised with a network, a router that is being advertised in we have advertised a network inside router ospf. Okay, then that router will send an hello packet on the multicast address 224.0.0.5. So here it is 224. By mistakenly it is given as 244. 224.0.0.5 multicast message. Okay, which can be learned, which can be heard by only the ospf running router. Okay, so this is something my initialization state. Okay, in then the router B, once it receives over here, it will say that I am router ID so and so, I can see no one. Now router B receives this on this multicast address because router B is also running ospf. Router B will send an hello packet saying that I am router ID so and so, I can see you. Okay, so here this is an initialization state, init state, you can say init. Then comes two-way state. Here in two-way state, they become neighbor. They become neighbor. Okay, and DR and BDR are elected over here. DR and BDR are elected over here. DR, BDR are elected over here. Okay, so they become neighbor over here, and DR and BDR are elected over in the two-way state. Okay, down state, initialization state, and init state and two-way state. Then comes xstart. Now both the routers became neighbor. Now they need to exchange DBD. Okay. Now in xstart state, they will fight with each other. Okay, they will fight with each other. I will start exchange because I have a router ID so and so. Then router B will say, no, I will start the exchange because I have higher router ID. Okay, so they will fight with each other. And in this xstart state, they will select that who will start the exchange first. Who will start the exchange first. Okay, so here DR, BDR adjacencies are formed. Adjacencies are formed. DR, BDR adjacencies are formed in this state, and they will select that who will start the exchange first, and in the exchange state they will exchange the database. You can see over here link state database, okay, DBD, database distribution also. See, both are same, both are given different names, but both are same, link state database, or you can say database distribution, DBD. So here is my summary of LSDB. Then A will also send its DBD. Okay, so all the routers within an area will have same database table, same DBD. All the routers within an area will have same database table. Got it? Exchange state. Then comes loading. Now, what is the use of loading state? Suppose B has sent the database table and A got the database table of B over here. And what A is doing over here, this is the database table of A, this is the database table of B. Now B is having some more extra routes which are not present in the DBD of A. Now what A will do in the loading state, if there are any missing routes in the A's DBD, what A will do, A will send an LSR packet, link state request. Link state request. He will say, suppose there is some network over here, okay, 172.16.6.network, and which was not shared by, which is not present, the information of this 172.16.6.network is not present in the DBD of A. Router A does not know how to reach this network. So what it will do, it will send an LSR packet. It will send an LSR packet, link state request. Link state request packet requesting that please provide me the complete entry for this network. Once the request is received by the router B, it will send an LSU packet, link state update. Link state update. Here is the entry for network so and so. Then once the router A receives the update, he will give an LSA packet, acknowledgement. Thanks for the information.
I have a question here.
Yeah.
So, how the router on the left side knew about the new network 172.16.6.0?
See what I told you, all the routers will be having same DBD. Okay. So once router B is sharing its database table, router B has this network information in its DBD. Okay. 172.16. But router A does not know about that network. So when router B is sharing the DBD, router A will compare the networks, if any networks are missing. So if there are any missing networks, he will request for that missing networks.
So it requests for what?
Missing networks, entry for the network, whatever
So,
network that is missing.
sorry, that's a question. So in the DBD which has been shared by router B, there was 172.16 entry, right? Based on that comparison, F came to know it's missing.
Come again?
Then why? See, on the you said A compared with the B database, right? DBD, and it finds something is missing. Then it can add entry there, right? Why it sends then LSR? Why not it takes
No,
entries
it
from the
cannot take
database
the entry.
DBD?
It only it does not have the complete route. It does not have the complete entry in the DBD. See, complete entry will be in the routing table. Okay, so DBD will be having only the networks that are advertised with the neighbors. Okay, all the neighbors within the area. If there are any network advertised, I will be only having that networks listed, that these all are the networks, and information how to reach that network. Okay, so B is having the information. Suppose I am on this router now, and this is 172.16.6.network is my LAN network. Okay, I have the information on B that if I want to reach this network, it is on my LAN. That information will be shared with the inside the DBD. Okay, so how the router A will come to know if I want to reach this network, where I have to go. So that information will be shared in the update packet. In the update packet, LSU packet.
Okay. Okay. DVD is not. DVD doesn't having those routing information, right? It's having only the neighbor router IPs.
Neighbor routes and the next hop address.
Okay.
So first of all, A will not have the entry of this network. A is not knowing about this network. Okay. B knows about this network because B is connected to this network, but B has its own next hop. That to reach this network, I have to go to this next hop. Suppose any next hop you can say, or to this router or to this interface. Okay, but A does not know about this network. So to get the information about this network, the complete entry of the network, there might be many IP addresses on this network. To get the complete entry of this network, A will send an LSR packet. Understood?
Yes.
So these are LSR, LSU, and LSA packets. Then comes my last state, full state. Now in full state, synchronization is done. Both the routers are having same database table. They are converged now. Okay, they are converged now. So it will show you as full state. Understood? Now, these are the packet types. Hello packet, discover neighbor and build adjacencies between them. DBD checks for database synchronization between routers. LSR request specific link state records for router to router. Okay, LSU sends specifically requested link state records. LSA acknowledges the other packet types. Okay. Now there is a concept of router ID over here. What is router ID? What is router
Router
ID?
ID. The highest interface IP
Okay. So what
address.
is actually router ID? What is the definition of router ID?
Router ID is the unique. It's a unique name to represent a router in a network,
Yes.
right?
Yes. It is a unique identification of a router. Like we human beings are known by our names and surnames. Okay. The same way the router is known in OSPF, the router is known by its router ID. Okay, by its router ID. So there is a process to select a router ID. Okay, so the first thing is manual selection. Manual selection means we will configure manually the router ID. We will configure the router ID manually. Okay, if we are not configuring manually, then router will automatically take the router ID. Now suppose if I give you an example how the router will select the router ID. Okay, so if we are not doing manual things, then the first thing that it looks, okay, the first thing that it looks, suppose these are the interfaces of router. The straight line are physical interface, and the above one, this is a loopback interface. Okay, so suppose I am having an IP address 12.0.0.1 over here. Over here I am having 192.168.10.24. Here I'm having suppose 10.1.1.1. Here I'm having some 172.16.0.16. Okay, so these are the IP addresses that are there on the router. Now tell me which IP address the router will select as the router ID. Suppose I add one more loopback over here, 12.0.0. or 1.1, you can say. There are two loopback addresses. Okay, two loopback addresses, and I have three physical interfaces. So which IP address will be selected as my okay
192.168.
okay who said this 192? Nilesh or Pawan? Pawan. Okay. See, whenever the router is running OSPF, okay, router will select, first of all, it will select the highest IP address of logical interface as a router ID. Highest IP address of logical interface. Loopback is a logical interface. So what is the highest IP address? This is the highest IP address of the logical interface. This will become my router ID. RID, you can say router ID, you know, of for this router. First preferable is manual selection, manually configure. If you are not manually configuring, then the router, if there is a loopback configured on a router, then the router will automatically select the highest IP address of the loopback. This is the highest IP address of the loopback, and the router will automatically select the highest IP address of a loopback as the router ID. Okay. If I am not having loopback, then it will take 192.168.10 dot. This will become my router ID. This is the second preference. Remember, physical interface is my second preference. If I'm not manually configuring, the first preference is loopback. It will look for loopback. If there is any loopback, if there are multiple loopbacks, it will choose the highest IP address among the loopbacks. Okay. If there is no loopback addresses configured, then it will select the highest IP address of physical interface. Okay. Understood? Router ID.
Yeah, I was missed. I forgot.
So sorry.
Yeah, I forgot that.
Yep. So the router ID is a 32-bit number or IP address used to identify the router. Okay. Cisco router chooses the router ID as the highest IP address of all configured loopback interfaces. If no loopback interfaces are configured with address, OSPF will choose the highest physical IP address of all active physical interfaces. You can manually assign router ID. Okay. The RID interface must always be up. Therefore, loopbacks are preferred. Got it? Okay.
I had one more question on OSPF, just to make sure I understand the concept all the way. So when it sends a database update from the designated router out and another router learns about that, all it does is update the database on the things it doesn't know and then request additional information on those routes separately?
Yes, it will request the route separately, whichever routes it is not having. It will send an LSR packet that so these many routes I am not having. How to reach these many routes? Send me the complete entry for these routes.
Gotcha. And that way it's not flooding for all routes every time, just about unknown. I got it.
It is only requesting the missing routes.
Understand.
That's
Thanks.
what it was given over here. What's this, Pawan, what you have said?
No, I understand. I just wanted to make sure I understood it, the concept. Thank you.
This link having, you know, the packet capture of DBD, LSR, LSU, so it's good.
Okay. Now we have some types of tables in OSPF also. Okay, neighbor table, we have database table, we have routing table. Okay, neighbor table, information about directly connected nodes. Also, it is sometimes known as adjacency table. Show IP OSPF neighbor will give me all the neighbors. Okay, then comes database table. It is also known as link state database. LSDB contains information about all the possible routes to the network. Now, one thing yesterday I just mixed up the EIGRP and OSPF concepts. So if you remember, I told you yesterday that in EIGRP, the topology table, I told you that it will have the routes that are, suppose I want to reach this 50 dot network, same example I am taking, I want to reach this 50 dot network. This is my router A, this is my router B, this is my router C, this is my router D. Okay, so if I want to reach the 50 dot network, I have three possible paths. I can go via B, I can go via C, I can go via D. So B is giving me the information that if you want to reach the 50 dot network, there I am having 5 possible paths. Okay, it is saying 3 possible paths. This is saying 2 possible paths. So what happens in EIGRP, among these 5 paths, the best path will be stored in the topology table. One best path. Among these 3, one best path. Among these 2, one best path. All the best route information from all the neighbors will be stored in the topology table. All the best route information from all the neighbors will be stored over here in EIGRP. Okay, so I just mixed the concept of OSPF and EIGRP yesterday. Now in OSPF, what will happen? All of these routes, these 5 routes, these 3 routes, and these 2 routes, all of these routes will be stored in the LSDB, contains information about all possible routes to the network, to the destination, all possible routes. Okay, all possible routes will be stored in the LSDB. Now all router should have same database table within the area. All routers should have the same database table. Okay, now to see the database table, you will give the command as show IP OSPF database. Okay, then routing table, as our global routing table for all other routing protocols, contains best route information. Show IP route is the command that is given for the route to see the routing table. Got it? Now here there is a concept of area introduced. Okay, area concept is introduced. Now why the area concept is introduced? Why we need area over here? What is the use of area? Why we need area? So there is an issue with OSPF. Okay, so suppose I am only having a single area over here, and these are the routers that are running. I'm just showing you a small topology over here. It might be it might be containing more routers over here. Suppose there are in between these there are many routers or something. So these are some routers. Now these are my low end routers. Okay, these are my low end routers. Okay, low memory routers you can say. And these are my some high end routers over here. Now within an area, all the routers will be having same database. Okay, so what will happen if I add a network over here? If I add a router over here, if I add a network over here, this router will update the information. this router will update over here. Okay, this router will update over here, then here, again and again I am getting updates on this router. It has to run SPF algorithm multiple times to select the best route, to select the successor route, to select the feasible successor. It has to run the SPF algorithm too often, because this is my router. This is only the router that is connected to all the other routers. And here, these routers are low end routers. So these routers are getting information about all the other networks in the area. Okay, so they are getting information about a network connected over here also, connected over here also. If there is a network, all the networks that are there, so it will be having a huge DBD. So what this router will do, sometimes might be possible the router will get crash, okay, or it will get rebooted. So my routing table is too big, I am running low on memory. Okay, so what will happen, sometime it will get crashed, or sometimes it might get rebooted. Okay, this router will say I am receiving too many LSAs. It is, we will see what are LSAs. Okay, it is this router is also sending update, and the down router is also sending updates. So I'm receiving too many LSAs. Okay, and this router will say again and again I have to select the best path, I have to run the SPF algorithm. So to overcome this problem, we came up with something known as area. Okay, now what we did, we divided this complete network into logical areas. Okay, logical areas. So any changes occur will be limited within the area only. This is my area 0, this is my area 1, this is my area 2. So if I suppose add a network over here, this network, if I add in area 1, this will be only having updated on this router, on the router that is running on the SPF algorithm will be running within the area only now. Okay, updates will be sent to the router within the area only. Any changes, it will impact the routers within the area only. Okay, and the DBD will be same within a single area. Okay, so one area router will be having all the routers in area 1 will be having same DBD. Previously, all the routers in area 0 were having same DBD, so it was becoming very huge. Okay, so that was the reason what we did, we divided the network into logical areas. Okay, logical areas. Okay, so this is why we need area over here. All router maintain same database table within the area. Any changes will impact all router in the area only. Now, what is the advantage of creating area? Decreases routing overhead. Now, if anything happens in other area, I don't need to bother about that. Okay, my router within in other area don't need to bother about that. Minimizes the size of database table. Okay, as the database is uh, limited within the area only. Restrict changes within the area. Any change that will occur, it will be restricted within the area only. Understood? This is something my concept of area. Okay, then I have conditions for area. Okay, to design area we have some conditions. Okay, so the first condition is we can keep 40 to 50 routers in an area. This is recommended by Cisco. Okay, always keep 40 to 50 routers within within a single area, recommended by Cisco. Okay, and the second condition is area 0 should be in the middle. All areas should be connected to area 0. Like I shown you over here, what I did, this is my area 0, this is my area 1, this is my area 2. Okay, these are my border routers, ABR, area border routers. ABR. Okay, this is also ABR, area border router. So see, here my routers are connected to area 0. All the areas are connected to area 0. I cannot make it in this way. This is my area 1 and suppose I made this as area 0. So my area 2 is not directly connected. So I will not get the information. This area will, area 0 will pass the information to area 1. Area 1 will pass the information to area 2. But no information will be passed to area 2 over here because this is not directly connected to area 0. Everything should be passing via area 0 only. Okay, so area 0 is my backbone area. If I need to design more areas, then what I need to do, I need to connect it to area 0 over here. This is my area 3. This is my area 4, suppose. Okay, like this way we can design our network. One ABR should be there, area border router. Area 0 is backbone area, other area are non-backbone area. Okay, ABR means router that belongs to two areas. Okay, that router will be running two areas. Got it?
And the area border routers do the route summarization. Is that correct? Do the area border routers do the route summarization?
Sorry,
Okay.
come again.
The area border routers,
Yes.
they do the route summarization for the area, correct?
Yeah.
Okay.
One question Qayyum here. So,
Mhm.
so we define area 0. This 0 makes as a one backbone network, or there are another specific command we run to make it as a backbone area.
Means I didn't got your question. Backbone means?
So, so whenever we configure area on the router, we define router network and then area 0. This area 0 command makes it as a backbone, or there is another
Yes.
command we run.
No. It only make the router as a backbone area. Area
So,
0 is the backbone area.
so area 0 is very specific, right? It should not be configured anywhere. It should be always in the middle.
Yes. You have to plan the network in that way that it should be always in the middle.
And let's say if we have 100 areas in a network,
Mhm,
then all the
mhm.
100 should be centrally connected to area 0, right?
Yes. All the traffic will be passing via area 0 only.
And if there is any topology where it's not connected with area 0, then the topology is wrong, or maybe that will not having the complete reachability with each other, right?
See, we can have reachability in that conditions also. In some of the conditions, what will happen that there is no way that we can connect the area with area 0. Okay. So in that situation, we have something known as virtual links.
Virtual links. Okay.
Yes. That will be studying. Okay. Don't worry. So these are my routers. Let me open this topology. So first we'll see single area OSPF configuration. There are more things in OSPF I need to explain you. But first we will see single area OSPF configuration. Then we'll move to other topics. Okay. Show IP interface brief. IP addresses are configured. I have loopback addresses also, you can see. Show IP protocol. No protocol. Okay, so I'll configure OSPF. So how to configure OSPF? Router OSPF 1. 1 is my process ID. Now my networks are over here, 10 dot network in the LAN. Then it is asking me wildcard bits. You know wildcard bits? What are wildcard bits?
It's the reverse of the subnet mask. So
Always
255 would be 0. It's take the subnet mask, subtract 255, and that'll give you the wildcard bit.
take the subnet mask and
Subtract 255, and that'll give you the wildcard bit. So 255 from 255 would be 0. 255 from 240, 15. That's the simplest way, I guess.
okay. So wildcard bits is something here you can see over here. Wildcard bits will be given with this formula: global subnet mask minus customized subnet mask. You will get the wildcard mask. Okay, global subnet mask is this 255, 255, 255, 255 minus the given subnet mask. Now this is for /24. If you are having something like 240, you can get it over here. Okay, 0.0.0.15. Understood? Wildcard mask. Wildcard mask. Okay. Wildcard mask are for network will be inverse mask, and wildcard mask for a single host will be always 0.0.0.0. For a single host, it will be always 0.0.0.0. Understood? These are my wildcard bits. So what is my 10 dot network? 10 dot network is my /8. So /8 will be having this wildcard mask. Then area. So I am looking for a single area configuration. Now it is asking me for area ID. So I can give the area ID between 02429496725. I'll say area 0. Okay. I've advertised my this LAN interface, then my WAN interface. Okay. I'm not advertising the loopback. On router 2, router OSPF 1, network 20 dot network with the wildcard bits as this area 0. 1 dot network and 2 dot network. Okay, see a neighborship came up. You can see adjacency form process 1 neighbor is this one. Okay, loading to full, loading to full. Router 3, router OSPF 1, network 30 dot network in my LAN, 3 dot network in my WAN, and 2 dot network in my WAN again. Okay, I formed a neighborship with R2. Router OSPF1 network 40 dot network, four dot network and 3 dot network. So I have to advertise 4 dot network in R1 as well. This is my single area OSPF configuration. Okay, if I want to see show IP OSPF neighbor, how many neighbors I am having on R1? 2 neighbors, 14 dot and 14.0.3.1. See, it took the highest IP address of the loopback as my router ID. Okay, it took the highest IP address of the loopback as the router ID of the router. So this is the thing. Okay. Show IP OSPF database. This is my database table. I am having each and every routes. You can see this is my database table. These are my router IDs of all the routers, all the networks that I am having. Okay, all the router IDs, all the neighbors, and here I'll be having show IP OSPF neighbor. See, on R2 I'm having 11 and 13 as my neighbor. Show IP OSPF database, same database table over here, and show IP route OSPF. I'll get the routes over here, OSPF routes. Okay, over here O routes means OSPF routes. Okay, understood? Show
Yes.
IP OSPF neighbor, show IP OSPF neighbor. Got it? So this is something my simple configuration for my single area OSPF. Okay, got it?
Got it.
Now if I want to configure multiple area OSPF, what I can do? Suppose my plan over here is I will keep, suppose I'll not use this link between R1 and R4. I'll just delete this link, or I'll just make the link shut down. Okay. And what I'll do, between R1 and R2, I'll be running area 10. Between R2 and R3, with the loopbacks and with the LAN, I'll be running, suppose, area 0. It should be in the middle. And over here, I'll be running area 20. Understood my plan? Multi-area OSPF configuration. In this way, I'll configure multi-area OSPF configuration. Okay.
R2 loopback is in 10.
Sorry?
R2 loopback is in area 10.
R2 loopbacks will be in area 0. R2 loopbacks will be also in area 0, and R2 LAN will be also in area 0. Okay, we can put it in anywhere. I've just made this thing. You can put it in, you can put the LAN of R2 in this network, and you can put the loopbacks in this area. You can do it anyways. Okay, there is nothing as per your plan. You can do anything. No router OSPF 1 router OSPF1. I'll remove it from all the routers. No router OSPF1. No router OSPF1. No router OSPF1. Okay. Now on R1 I have created a OSPF1 over here. Now network 10.network 0.255.255.255.0, sorry, area 10. This will be my area 10. Okay. 1.network will be also in area 10. Okay. So interface serial 3/3. I'll make this interface down. So consider the link is, there is no link in between these two routers. Okay, there is no link in between these two. It will not make any changes or something, just I am explaining you this thing. Router OSPF1, network 20.network will be in my area 0. 2.network will be also in area 0. And 1.network is in area 10. Okay, 1.network is in area 10. Router OSPF1. Now I'll put 30.network in area 0. The LAN of R3 in area 0. 3.network will be in area 20. Before that, 2.network in area 0 and 3.network in area 20. Okay. Router OSPF1. 40.network will be in area 20. And my 3.network will be also in area 20. Okay, so this is what I've configured the things. Now let me go to R1 and check show IP OSPF neighbor. I'll be having one neighbor, that is my R2 12.0.3.1. Okay, I'm having one neighbor over here. If I see the neighbor on R2, show IP OSPF neighbor, two neighbors, 1 and 3, two neighbors, 1 and 3. Okay, if I see show IP OSPF database, see now this is my database table on R2. These routes are for area 0. These routes are area 0 routes. These are area 10 routes. Okay, these are area 10 routes over here. Okay, understood on R2. Got it? Because R2 is my border router. R2 is my border router over here. Here I am running area 10. Here I am running area 0. R2 is my border router between the two areas. Okay, so I am having these routes over here. If I go on R3 and if I check show IP OSPF neighbor, I'll be having two neighbors over here. Okay, on R4, show IP OSPF neighbor, two neighbors over here. Understood? Sorry, one neighbor over here, that is my R3. And the state you can see, it is full state. Neighbors are fully converged. The state is full. full. Neighborship is full. They went through all the states. They went through all the states. Okay, understood? If I
Can
want to
you
see, yeah,
can you show OSPF database on R4?
on R4.
Okay. One more question here. So here it is showing the state full. It should show either BDR or DR, right? Under a state? No.
This is not a BMA network. We are not connected. This is point-to-point network.
Okay. So that is only valid for BMA network, right?
Yes,
Broadcast.
broadcast multi-access network. Okay, because we need, there is a possibility of loop in that type of network. If we are connected to a single switch or single medium, that is only the medium that all the other routers are communicating, then in that type of network we need a DR and BDR to be elected. Understood?
During the INET or exchange, you said the router between two routers, they compare and makes as a master or slave, right? That's different. DRBDR is different, right?
Yes.
Who will exchange the database first? They do the selection based
The
on
router
router
ID,
ID.
highest router ID.
So that's called master and slave, right? That's
Yes.
not DRBDR selection.
That is not DR BDR. They form the adjacencies as DR and BDR. They don't elect the DR BDR. Okay, they form the adjacencies as DR and BDR. There is no such DR and BDR. The router with the highest in the point-to-point network also, you can sometimes you can have the DR and BDR while the routes are not exchanged, because no router is knowing that what is the other router, what is the router ID of other router. To select the, to check the router ID or to start the exchange, what will happen, they will consider themselves as DR, but in the later parts they will know, they will not consider the DR BDR process. They will, the DR BDR process will not be running anymore in the point to point network. Okay, just when they are exchanging the database, the DBD, at that time to exchange, who will start the first, who will start the exchange first, at that time they consider the router ID. Okay, and how you can see what is the router ID that is taken over here? Show IP protocol 11.0.3.1 on R1, because it is the highest loopback interface. Okay, now if I want to configure, suppose manual router ID, I'll go in the router mode. I'll say router ID. I can give any IP address. Now what it is showing me, either reload or use clear IP OSPF process command for this to take effect. Okay, so I need to give a command, clear IP OSPF process. Yes. So it will reset the neighborship and the neighborship will come up again. Okay, if I see now, see my router ID is being changed over here 11.1.1.1. This is how I can configure the router ID manually. Got it? Any questions?
No, go ahead. Got it.
I can do it on all the routers if I want. One router ID, I'm on R222.2.2.2. Clear IP OSPF process. router ID 33.3.3.3, clear IP OSPF process. See the router ID over here. Okay, in this way I can change the things over here. Got it? Now if I see the routing table, show IP route OSPF, I am getting OIA routes. OIA routes means inter-area routes. OSPF inter-area routes. Okay. Inter-area routes means other area routes. OIA routes, they are advertised by some other area. Okay. OIA routes. Okay. If I see on R2, show IP route OSPF, here I will be having O routes within the area routes and OIA routes, because this is my border router. So I am running area 0 as well as area 10 on this router, but I am getting 40 dot and 3 dot network from area 20. So that is the reason it is my OIA routes. Understood? Any questions? Okay, just give me a minute. Got it till here? Now we can uh, do summarization also over here in OSPF, like we have done in EIGRP. Okay, so how to do summarization over here? So suppose I am on R1. Let us now I have already advertised do show run section OSPF. I have already advertised my WAN and my LAN interface. Okay, I will advertise my loopback interface also in the OSPF. So I'll say network 11.0.0.0.0.255.255.255 area 0. Sorry, area 10. This is in area 10. Okay, area 10. All the loopbacks I'll advertise. Router OSPF 1 network 12.0.0.0.0.255.255.255 area. I can keep it in any area. I will or let it be. I'll just advertise the R1's loopback. There is no issue. Just give me a second. Okay. So where was I? I have advertised the 11.network in R1. Okay, I am on R2 now. Now R2 is my ABR router. Okay, R2 is my ABR router. Now what is the benefit of route summarization? It minimizes the number of routing table entries, correct? It minimizes the number of routing table entries. Okay, so if I go and if I check on R3, show IP route Ospf, see, I'm getting individual routes that are being advertised over here for 11.network. I'm getting individual routes that are advertised over here for 11.network. Okay, so I want that this ABR should summarize the network and it should send it to other area. Okay, so if I do the summarization, if I do the manual summarization, how many bits I will get? How many loopbacks I'm having? I'm having 4 loopbacks. Okay, and my third octet is changing. The third octet is 0, 1, 2, and 3. Okay, so 0, 1, 2, 3 is my octets over here. So 0 is always all zeros. Okay, all zeros, and 3 will be 0, 0, 0, 0, 0. This will be 3. This will be 3. How many bits are common? 1, 2, 3, 4, 5, 6. 6 bits are common. Okay, 6 bits are common over here. Got it? So what will be my address now? How many bits are got common? 16 plus 8 plus 8, 16 from the first 2 octet, and in the third octet I got 6 bit common. So I'll get a slash value as 22. What is slash 22 will become 252. Okay, so this will be my summary address now. So how I will send the summary routes? Okay, on the ABR router I have to say router OSPF1. If I want to send the summary route, I'll say area 10 range, area 10 range. Okay, 11.0.0.0, 255.255.252.0. Okay, this is something I have summarized the routes. If I see now, I'll get only summary route over here. I'll get the summary route /22. What I've done, I've summarized the network. I've summarized the route. I've summarized the route over here. Understood? The command that I gave over here is area 10 range. Area 10 range. From which area the routes are coming? It is coming from area 10. It is coming from area 10. And the network that summarized address is 11.0.0.0, 255, 255, 252.0. Understood?
Yes,
Okay.
I had one question though, and I can't just recall the answer. So we don't use auto summarization because it'll summarize the whole class instead
It
of.
does not support auto summarization.
Oh, that's EIGRP.
Yes.
I'm sorry, my bad.
OSPF does not support auto summarization. It only supports manual summarization. Understood?
Understood.
Okay. So we have seen the summarization. Now, as Pawan asked me that if suppose I am if we design some network, some area in such a way that So I don't think so. We will be completing this topic. Let us start then also, because I have to leave you before 15 minutes so that the recording gets converted and I don't get late for the next lecture. Okay. So if suppose I have designed a network in this way, okay, these are my routers. What I did, I made these as my area 0, this as my area 1, and this is my area 2. Now my this there is no link in between this. Consider there is no link in between this. Now my this area 2 is not directly connected to this area 0. So no traffic will be passing from this area to area 0, or no traffic will be coming from area 0 to area 2. Okay, there will be there will be no connections between these two areas. Okay, there will be no connection between these two areas. Okay, area 2 will not have any connectivity with area 0 or area 1. So there are some possible solutions. What you can do. The first solution is extend this area 1 and take this router in area 1. This is the first solution. Extend the area 1. Extend the area 1. This is one solution. If you don't want to extend, because why you don't want to extend? Because as I told you, Cisco recommend that there should be only 40 to 50 routers. So in area 1, suppose there are 50 routers and you cannot add more routers in area 1. Okay, already there are 50 routers in area 1. You cannot add more routers in area 1. Then what you can do? You can have a physical link between the area 0 and area 1 router. You can have a physical link, connect physical link from area 0 to area this 2. A physical link between area 0 to area 2. Okay, there should be a physical link between the two areas. Got it? This is the second solution. Third solution is create a virtual link. Virtual link in the sense in this way. In this way, I will create a virtual link between two routers over here. Okay, between two routers over here, I'll create a virtual link. Okay, not in this way, sorry. In this situation, it will be these two will be the area border router. So between the two area border routers, I will create a virtual link. Okay, and I will say that these two areas are virtually connected. These area 0 and area 2 are virtually connected via this virtual link. Okay, so virtual links are used to connect a discontiguous area to area 0. This is discontiguous area. Discontiguous area. To connect this area to area 0, we need a virtual link. So the first solution was extend this area 1. Second solution was connect a link between these two areas. Third solution is very much common solution is, now there, why we don't connect, why we are not just connecting. Now there might be some situation that we cannot connect a cable between these two routers. Okay, so what we can do, we can move to the third solution, that is virtual link. Got it? Virtual link is a logical connection. A logical connection is built between the routers. Okay, between the area border routers, there is a logical connection built. Okay, virtual links are recommended for backup or temporary solutions only. Okay, they are recommended for backup or temporary solutions only. Understood? Why we use virtual links?
In bigger network, can't we have two backbone area? Why I'm asking this, because one backbone area, and because of this, there will be, more cabling required or more.
Okay. So just research this thing and just do a research on this and let me know if we can have two backbone areas.
Okay.
And why, what is the need of two backbone areas and how it will work. Okay, just do research on this and let me know, all of you. It is a very good question. Okay, so just do the research on this and just let me know tomorrow with the reason. If it is possible, then how the how the traffic will be passing, how the other areas will be selecting the which is the backbone area, which will be the backbone area for that particular area. Okay, and if it is not possible, why it is not possible. I want you, all of you, to research this thing on, do a research on this thing. Okay, and let me know. Understood?
Yes.
Okay. So where was I?
Were you going to do the virtual link, or
Sorry?
were you going to show us a demonstration of the virtual link, or no? Is that not possible between the areas?
That's what I'm just looking. Is it possible or not?
I gotcha.
So why my topology is in this bad condition? Okay, so virtual link, we'll first see the theory part for virtual links. Virtual links are used to connect this contiguous area to area 0, like this over here. I have in the diagram, this is area 0, this is area 2, this is area 3. Okay, now area 3 is not connected to area 0. So what I can do, either I can connect a physical link between these two areas, okay, or I can extend this area 2, or I can have a virtual link. Okay, I can have a virtual link. So see, these are the three solutions. These are the three solutions over here. Okay. Now this will be the topology that I'll be using. This will be the topology that I'll be using for virtual links. Okay. My loopbacks will be in area 10. These three routers will be in area 20, and between R2 and R3 and R4, I'll be running area 0. Okay. So this will be my topology that I'll be showing you. Now configuring virtual links. There are some things you need to remember whenever you are configuring virtual links. Identify the virtual area. Virtual area means with the area that is in between the area 0, that is connected to area 0. Okay. So here my virtual area is, in this example, my virtual area is area 20. First thing, you need to identify the virtual area. So the virtual area over here means that is in between the area 0 and your area. Okay, that is directly connected to area 0. Okay, so this is something. Area 20 is my virtual area. Identify the border routers of virtual area. So the border routers of virtual area, one border router is connected to my area, that is area 10, and one border router is connected to area 0. So these are two border routers. Okay. And router ID of border router should be manually configured. You need to manually configure the router ID of the border routers. See why we need manual configuration of router ID? Why we need manual configuration of router ID?
You wanted a specific designated router?
No,
See,
whenever if any loopback changes or higher loopback interface comes up, then this will be, the routing will break and everything.
Yes, perfect. So we are forming a virtual link between two ABRs, and we are forming this virtual link with this router ID. Okay, so suppose as per my router ID concept, it took the highest IP address of the loopback. On this router, it took this router ID. Now in future, suppose what happened, I removed this loopback, or what happened, I created one more loopback, 0.4.1, and after creating this loopback, I gave a clear IP OSPF process command. Then this became my router ID of this ABR. And what I did, I configured the neighborship on this virtual link. I configured the neighborship between these two routers with this router ID. Now my neighborship will go down. The virtual link neighborship will go down. Now they cannot communicate with each other. They cannot send routes. That is why always you need to remember, you need to configure router ID of the border routers manually in virtual link. Understood? I'll say whenever you are configuring OSPF, configure the router ID manually only. It will be not an headache. Whenever you are configuring OSPF, configure manual router ID only. You can take any IP address. Understood? These are the three things you need to keep in mind. First, identify the virtual area, the area between the discontiguous area and area 0. Then identify the border routers of virtual area. So border routers of virtual area are R1 and R3. Router ID of border router should be manually configured. Okay, as I told you. So you understood the plan over here. This is the plan. I'll keep it over here, or I'll take the image. I'll paste it over here. Okay, so it will be in front of you and you can see all the things. Okay, so first of all, I'll remove all the things. So I'll just say no IP routing command. If I say no IP routing, the routing will be disabled. Okay, it will remove all the things. I will enable the routing again, IP routing. Just one command, it will disable the routing, no IP routing. Don't forget to enable routing again. If you're using this command, don't forget to enable the routing again. No IP routing. Okay. If I see show IP protocol, there is no protocol running over here. I'll configure the OSPF configuration. I'll advertise the interface using multiple areas. Okay, as defined in the diagram, you can see. Okay, I'll configure the manual router ID on R1 and R3. Then I'll make sure that loopback interfaces of this area 10 should be seen on all the other routers. Okay, so on R1, I'll say router OSPF1 network. So first I'll use the router ID 11.1.1.1. Okay, this is the router ID. I'll advertise the 11.network to 255.255.255 area 10 as per my diagram. Okay, then I have area 20 and I have my 1 dot network in area 20 and 10 dot network is also in area 20 as per my diagram. Okay, 1 dot network and 10 dot network in area 20. On R2, router OSPF1, all the networks will be in the same area, so I can use this command. Let me check if it is working over here. Show run pipe section OSPF. All the networks, I'm considering all the networks over here. Okay, with any subnet mask. Okay, or you can give individual also. You can give individual. Let me check if it is working over here or not. On R3, I have border router as my R3. So router ID will be 33.3.3.3. Okay. Then network, as per my plan, 30 dot network is in my area 20. 2 dot network is also in area 20. And 3 dot network is in area 0. Okay. So see, I formed a neighborship over here with 12.0.3.1. On R4, router OSPF1. Here also, all the networks of R4 are in single area, so I can use this command to advertise all the area in all the networks in single area, or I can give the other commands also. Okay, if I go on R2 and if I check show IP route OSPF, here I am getting 3 dot network as OIA routes, 40 dot network I am getting as OIA routes. Okay, on R2 I am getting 14 dot networks as OIA routes. I am getting 30 dot network as my O routes. Okay, but here I am not getting the 11 dot network, the 11 dot loopback. If I go on R3 and if I check the same command, show IP route OSPF, I am getting all the networks except my 11 dot loopback. R4 show IP route OSPF. All the networks are there, but I am not having loopback, 11 dot loopback. Correct? Okay. No routes from the 11 dot network, 11.0.0.0 coming in the routing table of R2, R3 or R4 as it belongs to area 10. Why it is not there? Which is because it belongs to area 10 and which is not directly connected to area 0. So in order to make sure that the loopback of R1 router, that is 11 dot network 11.0.0.0 route should be seen on all the other routers, we need to configure a virtual link which allows area 10 to area 0 virtually. Okay, connected, okay, over area 20, the virtual area. So first of all, we need to go on the border router and we need to see show IP protocol. So if I see show IP route OSPF over here, I am getting the routes over here because this is in my, I am not getting the 11 dot network over here also. So now show IP protocol, first of all on the area border router, go on the area border router and of the virtual area and check what is the router ID. So here it is 11.1.1.1. This is the another area border router of virtual link. Here it is 33.3.3.3. Now Once we
Just
verify,
1 second. Okay. On R1, we can see the route for a route of R4 router, right? Interfaces like
yes,
40.
yes, because it is in area 20. See, R1, I have advertised these routes are in area 20. So area
No.
0 routes will be advertised in area 20.
Okay.
Understood? It is directly connected to area 0. So they will be advertised in area 20.
Okay. But area 10 will not come to area 1
No,
because there
because
is
it is
no
not
direct
directly
connection.
connected. Area 10 routes will not be coming to area 20, neither it will be going through any of the router. See, it is not there over here also.
Then from one side the ping should work, right? From R1 side the ping should work.
Yes, from
Okay.
R1 I can ping the 14 dot network. If I want to ping the
But from
14 dot loopback, I will be able to ping.
but from this side it will not work, right?
But
From
from
R4 it will
R1
not work.
itself, I will be not be able to ping this loop. I am able to ping because I am on the same router. Okay. But from R2, if I try to ping the, sorry, not 192, 11.0.0.0.1. I'm not able to ping because I don't have any routes for 11 dot network. I cannot reach the 11 dot network. So I will give you the routes via virtual link. So how to configure virtual link? Go inside router Ospf mode and you have a command over here, area 20. This is my virtual area. Area 20. You have to give a command which is your virtual area. Area 20. Then virtual link. Virtual link. Then the neighbor routers, the neighbor, you can say the router with between the other ABR router on which you want the router ID of the other ABR router on which you are connecting the virtual link. So this is my router 3's ABR router 3's router ID on R1. Okay, this is only the command that you need to give on R1 on both of the area border router. Okay, virtual area is area 20 and virtual link between 1.11.1.1.1. See, I got a syslog message over here. OSPF process adjacency up with neighbor 11.1.1.1 over OSPF virtual link 0. The state is full. If I see the neighborship over here, show IP OSPF neighbor, I will be having 3 neighbors now. I will be having 3 neighbors. 14 dot, 12 dot and 11 dot with the virtual link interface. Okay, with the virtual link interface. On R1 also I'll be having 3 neighbors. So IP OSPF neighbors. 2 neighbors, sorry, not 3 neighbors, 2 neighbors over here. Okay, the state is full. If I will check on R4, show IP route OSPF, now here you can see I am getting the 11 dot network over here as my OIA routes. Understood?
So you
Virtual link.
create the virtual link between the R1 and R3, and you
Yes.
ran those commands on both, right? Okay, I got it.
So these were the command. I said area 20 is my virtual area and form a virtual link with the neighbor 33.3.3.3. And here what I said, form a neighborship with 11.1.1.1.
Got it.
Got it? Any questions?
No, I think this was not the part of ENCOR, right? But it is good you explained.
This was the not part of?
ENCOR syllabus?
No, this is not a part in ENCOR.
410, no.
See, many of the things are not part of ENCOR. Okay, but I am giving you the knowledge.
Yeah.
Okay, because if you go at the CCI level, no one will explain you in-depth things. Okay, leaving Octa networks, because in Octa networks, if you are sitting, the Robert is sitting the CCI batch. I don't know about you all. So Robert is sitting the CCI batch of Abid sir, and he is very good faculty. Okay, with more than 25 years of experience in this networking field. He is the one person in enterprise networking. He will give you in-depth knowledge from CCNA. He will start from scratch from CCNA. Right, Robert?
Yes. Yes.
Oh, what is the name? What you told the name?
Abid Khan.
Okay.
He has more than 25 years of experience, okay, in this field. So he's a very good faculty. So in Octa networks, if you are pursuing CCIE, then it is best. If you are not pursuing in with Octa networks, no one will give you this basic knowledge about the virtual links, stubs, and all these things. Okay. Got it?
Got it.
What is the topic for tomorrow, Qayyum?
We'll see the network types like point to point, what is point to point, what is DMA, how DR, BDR are elected. Okay, what is non-broadcast multi-access network, NBMA.
Okay.
Okay, then DR, BDR elections I told you. Then what is the next topic? LSA types. We will see LSA types. OSPF LSA types. We'll see stubs. OSPF stubs. Okay, what are the stubs? What are the types of stubs? How to configure the router as a stub? Okay.
Okay. Thank you.
Most of OSPF will be covered over here. Most of the topics in OSPF will be covered at your CCNP level only, which are not there, but still I am explaining you. Okay. Any questions?